Okay, so this is the education workforce development session within the next hour or less than an hour, which isn't obviously, which isn't divorced from the research part of the center, and we're hoping to have even more um, engagement going forward. If we can go to the next slide. I'll start with a sort of a very general 30-second overview, and then we'll dive into each of these. This is not the only set of goals, but these are the main goals going forward, I should say. And that's, I'll start talking about the curriculum development that we've been engaged in. Most of you know that I've come into the center on year 3. At that time, we had our initial plan, which we pivoted a little bit, mainly because we wanted to prioritize the sort of unprecedented growth and the momentum that we have in the AI space and bringing that to Spectrum. So right now, our goals are going to be more around radio systems, AI, and Spectrum, and then spectrum valuation and policy by the end of the year, setting up 3 courses that are that I'm going to get into detail in a minute. And then we have our second goal, which is running a national scale summer school program at multiple sites. This was a first run as an experiment last year on 4 sites. And this year we have 2 more sites and 2 that ran previous year. So total engagement to date, I would say, is 6 campuses, and we want to grow this further in the next year as well. Our U program, which we're very proud of, Anja will talk about that in detail. Also running that at the national scale. Every year we run it basically about 12, 12 or a little more students, and the goal is to grow that subject to additional funding. Next slide. All right, so that brings me to the next few minutes. I'll be talking about our higher ed curriculum development efforts. So that's undergraduate and graduate. And as I mentioned, our current plan is to complete these 3 courses listed: radio systems and applications, AI and spectrum valuation and policy. This is also in sort of the reverse order of our progress. So radio systems and applications is one that we have the most development to date. And then the last one we haven't quite started yet, that we need to get going on that this year. Next slide, please. Okay, so our main goal in curriculum development is that we want to have educational content at the higher ed level that is multidisciplinary, accessible to broad audiences, and also not included in traditional curricula, at least as it is grouped, in order not to sort of repeat an effort that already exists. So we have an approach that we're hoping is going to really model the course development going forward, and this is something that is going to go on as spectrum science advances. So we want to make sure that we have a template that works well and that's scalable at different levels. And so much like the research and setting up the center in general, this also took some time to establish, and there was an effort. This is before even I joined, Nick leading the effort with Notre Dame Learning, that actually developed a course plan in radio systems and applications. Our recent progress to report in this is that our videos are now released. These are general videos that are teaser videos with for 4 different topics, and also videos that have been featuring leaders in who are stakeholders in Spectrum. So we have a whole playlist now on YouTube. And what we're going to be doing is adding more technical content to these. Our target platform is Coursera, and we will see how it goes, because I think we need to try this first one out and see what's the best way to disseminate a large scale course. Of course, Coursera is an established brand, but also things are happening on a daily basis in the education domain, so we shouldn't miss anything, in my opinion. Next slide, please. Okay, so just to kind of mention this, and I'll get into a little bit more detail as well going forward of the model. As I mentioned, the so quote unquote teaser videos that have interviews with the leaders of stakeholders with the goal of engaging, increasing interest in the particular space that Spectrum is important. The cellular communication part is obvious, but there are so many other uses of Spectrum that the general public is generally not that aware of. And so this playlist aims to do that, and also sort of combine, if you like, be a bridge between the different lesson plans. And this also sets our first layer. These are all accessible to general public, general in the sense of, someone who's not necessarily an engineer, but who's somewhat open to hearing about these. So this one here that we embedded it just introduces the module of radio interference, and I want to play it here so you can see the level and also the quality.
Is the sound coming through?
Not quite, Anja, if you could maybe.
This interference is an unavoidable part of physics. When multiple radio waves exist in the same space, they naturally combine, a process called superposition. But if a signal is too strong or poorly managed, it can drown out or disrupt other important transmissions. To prevent harmful interference, radio spectrum use is carefully regulated at national and international levels. These regulations are based on technical models predicting how signals interact in different environments, measurements and analysis studying real-world data to understand interference risks, and system sensitivity testing, evaluating how different radio receivers respond to interference. There are several key strategies to ensure that different radio systems can coexist. Frequency allocation, assigning different frequency bands to different applications and dividing bands into channels for specific systems. Geographic restrictions, limiting where a system can transmit to prevent interference in critical areas. Power limits, controlling how much power a system can transmit, especially near sensitive receivers. Listen before talk. Some systems must first check if a frequency band is in use before transmitting. Dynamic spectrum sharing, using real-time databases to allocate available frequency bands based on location and demand. Every regulation strikes a balance between technical feasibility, system compatibility, and the growing demand for more wireless connectivity. To explore these innovative approaches, we'll hear from leaders in the field. Intel, a Wi-Fi technology leader discussing spectrum access for unlicensed devices and their coexistence with microwave links. NTIA, the National Telecommunications and Information Administration, Institute for Telecommunication Sciences, conducting measurements and analysis to reduce interference between aircraft radar altimeters and new cellular deployments. WIN Forum, the Wireless Innovation Forum, developing spectrum access systems and environmental sensing capabilities to help Navy radars and wireless networks share spectrum efficiently. As demand for wireless technology grows, managing interference is more critical than ever. In this topic, we'll explore how technical solutions, regulations, and innovation work together to keep our increasingly connected world running smoothly.
Okay, so next slide. I hope you agree, a lot of work has gone into developing these videos. We've shown a couple of vignettes in earlier meetings, and this one I wanted to show because it shows Nick introducing the topic, and then there'll be additional content put in by instructors. In doing this, we're trying to, in a sense, reuse efficiently our resources, which is also in line with the topic of the center. We're following a layered model. So this, what you saw is a first layer, which is a non-specialist view with these videos. As well as the interviews from different leaders, also was mentioned in the introduction video. The second layer is going to be suitable for an undergraduate course. Those lecture modules are going to be for, let's say, junior, senior level undergraduate, perhaps a junior level undergraduate. So still not super deep in terms of math, but is more technical. Introducing at the undergraduate level to a student who has taken some level of math type of courses or have interest in spectrum, even if they are not necessarily engineers. If I can, yeah. So, and then the potential third layer is a kind of a master's level. So this is for someone who already has a STEM BS degree, right? So then you can go into a lot more mathematical models and kind of really go into these topics. So that's kind of our model, is to build in layers and have these modules. Basically building these skills at different levels. And we thought that it would be a good idea to have different modules developed by center members, both to kind of distribute the load and to ensure that we have coverage from different members. If we can go forward. So this crowdsourcing effort has started with a survey we ran in winter in February, I believe. We've identified 11 potential instructors from 8 member institutions who responded positively to being interested. And we asked questions like, what do you already have? And of course, many of these instructors have taught topics that are relevant to these courses, including radio systems. So that's how we're starting. We have also expertise that's collected for, in general, spectrum economics and policy implications. So that's going to mainly go into the third course. And so we're in the process of getting back to volunteers with specific asks, because of course there's also overlapping interests. So we have to kind of try to amortize that. If you're interested, there's still time. Please just send an email to me with your expertise, or I can contribute in this, and then we can try to do our best to accommodate your contribution. Again, particularly going with the third layer, we're also looking into research contributions. So if we can go forward, maybe I'll pull up the other model. Right. So this is the AI and Spectrum course that became, I think, it's sort of a necessity given the advent of AI in the past year or two, and its increasing role in next generation communication. So it's pretty clear that 6G is going to be AI native, and that means that with the flexibility of open networks and cognitive radios, I'm using the term intentionally. Recently, we have lost the inventor of cognitive networks, cognitive radios, I should say, Simon Hyken. But the legacy still goes on in programmable radios and being able to be flexible. So these are all steps that have been taken over the few decades to bring us to this point. And now that we're in a situation where we can really design automated spectrum sharing policies for next generation, we should also be teaching that so that our students are ready to hit the job market. And so this is the goal of this course, is to develop that workforce. So we're having a slight different starting point here, in that we have a DISPAN tutorial that's being developed by our center, which will serve, parts of which will serve as the foundation for this course. We'll still develop the course plan and the modules, etc. But we have already a nice set of resources we can start from. And I'd like to credit Mariya because this was really her idea, connecting the research community that's developing this to the education workforce development. And so in this one, the third layer would be, in fact, the research we're doing in the space, whereas the first and second layer in particular would teach the basics at a technical level. So that's, so the next slide, please. So that's all I have. And in curriculum development, we'll take questions at the very end. So I'd like to hand it off to Anja for the RU program and the Citizen Science Project updates.
Thank you very much, Aylin. And really, as Aylin says, we'll just be focusing on the RAU Plus program, which is our summer research experience program, as well as the Citizen Science Project, which is currently under development. But just to clarify that the research experiences program consists of two components. There is the RAU Plus program, which, as I said, is for the summer. And then, as many of you will know, because many of you host them, there are also undergraduates who are doing research at member institutions throughout the year. So focusing on the REU program specifically, for those of you who are new to the center or to this meeting, currently we run a 10-week, what we call an enhanced research experiences and research experience program for 12 students a year, and that is being run from year 3 to 5. And of course, we're currently in year 4. And what we do is to recruit mentors and host institutions from our member centers or member institutions, and actually host REU students across those centers. So last year we had 4 host institutions. In 2025, we're looking at the National Radio Astronomy Observatory, University of Notre Dame, UC Boulder, and UVA. So thank you very much to those host sites. We have a presentation available, and I'll chat to you about that in a moment, just with information about what is involved in being a host site. So, really, if you are interested in hosting some of our REU students next year or throughout the year, please get in touch with us and we will help coordinate that. So why is it enhanced? So in addition to sort of your typical REU components or model, really what we look at SpectrumX is sort of, working very closely with students and giving them dedicated support to keep them within the SpectrumX community and the Spectrum community going forward. So we look at cohort activities, and that is, across the 4 sites. So there'll be a shared calendar with those cohort activities, and of course, students can participate in the REU cohort activities at their host site. Tailored professional development. So we work with each student, to determine what skills, the student really may need to improve before they embark on their project for the summer. Or also looking at, general professional skills. If there's a student who's really interested in project management, can we get them connected to do some project management training over the summer and possibly writing the Certified Associates in Project Management exam. We offer senior and mentor training for both the senior mentors and the near-peer mentors. And of course, the near-peer mentors are generally graduate students that the mentors would bring in to assist them. Student support, and this is really dedicated student support. So from our office here at the National Radio Astronomy Observatory, really our job over the summer is to be that dedicated support for the students. Of course, they also have their coordinators at the sites. But really, if the student is coming across any barriers or hurdles, whether it be financial, mental health, struggling to connect with their mentor, whatever it is, really being available to the student during the summer. And then, of course, travel support, which comes through the center budget for either a center meeting or a conference of their peers, such as the AAS. So we would love for other member institutions, PIs, as well as industry to get involved. We are looking for host sites, that can host 2 to 4 students a year. We insist on sending them as a cohort of 2 so that none of the students are alone. Our virtual information session for potential host sites will be scheduled for the 5th of September, 2025. So if you're interested, please shoot me an email, but of course a call will go out before the time. And we're also looking for funders or sponsors who can help us to grow the pool of students that we are able to, host at different institutions over the summer. We're looking at a cost of about $11,500 per student for the entire summer. That includes their travel, their stipend, their meal allowance. What am I forgetting? Everything, essentially, accommodation. So, please get in touch with me. We would love to talk to you about either sending you one of our students or, collaborating to scale our program, or, if you want to host a student at your industry, for example, please let us know. We are happy to facilitate that matching process. So moving on to the Citizen Science Project, in a nutshell, this is a project that is built on some work that was done through a SciNerds grant here at the NRAO and, brought to SpectrumX. And that is really using, RTL SDR kits, which I'm sure many of you are familiar with, to create a heat map of live radio signals across the US. So looking at sort of radio frequency and, of course, RFI. So we created a citizen science kit, which is branded, which includes, this sort of the top of the range, super duper RTL SDR kit, as well as a guide, which includes setup instructions, additional activities, and then the kit also comes with some SpectrumX swag. My colleague Valerie Bogan has been leading this project and has, distributed citizen science kits that's been happening in year 2 and year 3. We still have, of course, kits to distribute if you're interested. We prototyped, really this kit, the instructions, the activities in year 2 and 3. And now we're looking at distributing the remaining kits in year 4 and 5, of course, through SpectrumX, but also through other networks, for example, the SciStarter Library Network. That is this year and next year. So how can you get involved? Well, this year we have a summer student who will be hosted at the NRAO, who's going to be helping us to get that the SciStarter page developed. That is, of course, one of the major citizen science platforms here in the United States, funded by the NSF as well as other sponsors. And so that student will really be looking at the interface that citizen scientists will be using. So developing that page, which of course has to include things like the GUIs, the composite APIs, the login systems, the project finder widgets, etc. And once that is set up and prototyped, we are going to be needing volunteers who are willing to help us collect some data so that we can prototype the page. And we're looking, for September to February next year. So if you or your students, are interested in getting involved in helping us to collect this data, as I said, the dates are there. We will provide a citizen science kit if needed. And I say if needed because I know you all have one in your top drawer. Please reach out to Valerie and, she will be very happy to get in touch with you and to coordinate, participation in prototyping from there. And that's it from me. And I'm going to hand over to Mariya to talk to us about the summer schools.
Anja, there's a question from Mariya in the chat. If you could speak to that.
I put it in. I don't know if we can just,
Sure.
answer later or however is best.
I'm happy to answer now. So it's actually a very good point, and I'm glad you raised it, Mariya. So we had 72 applicants this year. That's, almost double what we had last year. And only 12 get accepted. So, really there, and what I can say, two things that I did notice this year compared to last year is firstly, the quality of the students that applied to this program were honestly phenomenal. I mean, the top 20 were just absolute stars. But secondly, also that the number of computer science students applying also doubled. So there is definitely a need, for more computer science focused and data science focused projects. Of course, currently the majority of the mentors are electronic engineering. So, it would be great to have colleges, universities, and industry who are willing to, have students working on the computer science projects. That's good.
So hence the urgent need for AI and Spectrum course.
Yeah.
Okay, Mariya, please.
All right. Thanks everyone for joining us. I'm here to talk to you about the summer school SpectrumX programs. So Anja, if you could advance. So I've been running a version of the summer school for 4 editions now. The first time we offered it as an enhanced opportunity through SpectrumX was this past September. So it was offered as a 4-day activity from the 19th to 22nd of September 2024. And it was offered in 4 locations as host sites. So those included Hamilton College, University of Puerto Rico in Mayagüez, Florida International University, and University at Albany. In terms of instruction, I was sort of covering majority of the instruction for the course. And Karen Doak, who's my former student and now professor at Hamilton College, covered various topics around software-defined radio-based sensor design, data, what does it mean, how do you think about data? So we essentially co-instructed, and then Vasu and Andrew, who are also my students, were heavily involved in facilitating across sites. Special thanks to Professor Leon, Professor Madanayak, and Professor Hodges, who all helped us facilitate just offering those schools at remote locations at UPR, and particularly in Florida International as well. So next slide. In terms of what took place last year, over the course of the 4 days, we basically were split into about a day and a half of lecture style instruction, and then 2.5 days of hands-on activities. And I should point here that the target audience for this summer school is undergraduate students across the entire level of undergrad. So last year we had students who were just barely learning about Python, all the way to students who were very confident programmers, but didn't know anything about Spectrum. And so, the hands-on activities were able to sort of reach people where they were, which was very exciting. At the bottom table here is a breakdown of in-person and virtual participation across the 5 sites. So for lecture style activities, we were able to reach 61 students, and then 41 of these were able to participate with the hands-on activities on site. So next slide. Right. Oh, one too fast. Yeah. Okay. So as I mentioned, we had 1.5 days of lecture style content, and I'll, just in terms of what lecture style material was presented, we talked about basically how the internet started and where Spectrum became very important for internet access. And we have a lot of emphasis then on how do you access the spectrum, how is policymaking for spectrum generally run, and we ground all of this discussion in technologies that students use on a daily basis. So we learn about how Wi-Fi works, we learn about how cellular network work, we learn about the principles of spectrum access and regulation behind those two day-to-day technologies that students use. And all throughout the lecturing, we try to draw on students' firsthand experiences with those technologies to then delve into design principles and choices. So following the lecture style, we get into hands-on activities. We have a Wi-Fi lab that basically takes over half a day, where we build a Wi-Fi network and then try to break it in various ways by introducing interference, by moving around with respect to the Wi-Fi access points and introducing obstacles or distance. And all throughout this, students learn about network traffic injection tools such as ping and iPerf, and they also learn about network monitoring tools and some about data analytics at higher level protocols. And then we move on to another set of hands-on activities, which is a hackathon and a scavenger hunt that spans over the remaining day and a half of the summer school. Here, students go through a wide range of activities, from setting up their own, from learning first about what software-defined radio is and how to build a sensor out of a software-defined radio, sort of setting up their own sensors, through, going through a list of activities in a scavenger hunt style pursuit, where they're supposed to measure and collect data of a list of activities that we've kind of pre-curated. And then they get into data downloading, data analytics with Python. And then as far as their capabilities and imagination can take them in terms of tinkering with data. And for the last day, we talk about how to give a compelling presentation. Students have time to build their own presentations. So those are, essentially the hackathon teams. And here I have just a couple of photos of students presenting on their work from the hackathon activities. Next. So highly non-trivial with the 4 sites, but very successful execution for last year. There were lessons to be learned in terms of logistics that we're taking by heart with our design for this upcoming year. Students really enjoyed the hands-on activities as a learning opportunity. And as I mentioned earlier, the hackathon really allows students to engage at their level. Some were seeing Python code as very early sort of programming learners, and they just stopped there with the stub baseline that we had given them and played with that to understand a little bit about, Spectrum data and about Python coding. Others who were more advanced got into Spectrum analytics and developed their own methodologies building on the stub baseline that we had given them. They were really motivated by formal certification. So one of the photos here shows a certificate of completion that were awarded to the students, and they felt that this could boost their career credentials. And they were all very interested in ways to stay connected with the center. So next. So this sort of moves into where we are in terms of planning for this year. So the summer school, one of our key takeaways is that last year we offered it too late into the school year, and students got busy with coursework, and that created challenges for immersing with the school. So this year, taking the majority of host sites, we will be offering it during the weekend before classes start. So we're trying to hit the sweet spot where students are already on campus, but they're not busy with classes yet. So it happens to be August 22 through 2025 is the period for which we have planned this. We have 4 host sites again: National Radio Astronomy Observatory, University of Puerto Rico at Mayagüez, the Ohio State University, and University at Albany. And we're really excited to have a scientific user as the host site for the first time, because the school has been fairly internet-centric from application standpoint. And our goal is really to start honing in more on the diverse users of Spectrum in recognizing the importance of it as a resource for many more than just internet access. The co-organizers are myself and Aylin, with Lida Leon from UPRM and Anja Fourie from NRAO as site coordinators. And we will grow the team as we get closer in terms of more graduate students involved to facilitate labs. So there will be more updates on that as well. Next slide. In terms of what we're looking to deliver as lectures, we really want to focus more attention on the importance of the radio spectrum across applications. The spectrum history, rights, and regulations as a more sort of segregated, defined topic within the course, as opposed to something that's been running so far with the technologies that were discussed. We will continue focusing on, driving principles and challenges of wireless network design, including issues such as the wireless link and why is it so different than just running a wire, signal propagation and wireless channels, and all the challenges that this pertains. We'll continue grounding our discussion in popular commercial technologies, because this tends to bring out really good questions from firsthand experience. So we'll continue talking about Wi-Fi and cellular networks, their architectures, how they use the spectrum, and how spectrum regulated very differently for both of those. And then we'll continue going into emerging technologies and coexistence issues, discussing some of those emerging big ones as well. We will be approaching SpectrumX affiliates to actually prepare some of those topics here. And the idea is really to create more opportunities for SpectrumX affiliates to interact with those really good undergraduate students, and vice versa, right? So that students get exposure to more folks who participate in the center. We hope to be able to get people to host sites. So the center will be funding lodging and transportation and compensation for efforts to develop activities. All right. So next slide. Not a ton of change. So for now, at least planned in terms of the hands-on activities. So we'll again be anchoring in what was developed and delivered in the past. There are links here to a couple of sample demos from COVID versions of the schools, just to give you an idea of what people do for the Wi-Fi lab. And then last slide, please, is just to say we're really looking forward to creating even broader experience for those students and for ourselves as a center. If you have any feedback and ideas, please reach out to either myself or Aylin. That's it.
Great. Thank you so much. And then last but not least, we're going to hear from another Mary. Mariya Knapp from Haystack.
Hi. Hi, everyone. I'm Mariya Knapp from MIT Haystack Observatory, and I'm going to talk a little bit about the Mobile Experiment Platform, or MEP, student workshop that we held in November of this past year. So if you go to the next slide, please. All right, so here's an overview as well as our group picture with our big radome in the background. We had this workshop in November of last year, the 12th through the 16th, at Haystack Observatory. We had 19 participants. I put the tilde because there was a bit of blurring between participants and lecturers. So, it was a pretty integrated group with kind of blurry lines between who was participating versus who was lecturing. But the group included a number of graduate students, as well as staff and faculty. And actually, there were 2 undergraduates. That's a typo on my part. So it was a diverse group on a lot of axes. And it was a really fantastic group of people. We had a great time. We had in excess of 10 Haystack staff members participating as instructors in various capacities, lecturing and helping with technical work. The goals for the workshop were kind of twofold. The first was training in RF hardware and software, spectrum monitoring, and field work. And this is to support future field experiments that we want to do with these mobile experiment platforms. If you didn't see Frank's lecture about that yesterday, definitely check out the recording. We go into some detail about these mobile experiment platforms and what they're for and the set of experiments we plan to do with them. And the second goal of the workshop was constructing and testing these MEPs, culminating in an on-site field experiment, which I'll talk more about in a moment. We also scheduled this meeting to coincide with a center review. So it was very busy at Haystack for a week. Let's go to the next slide. So here's the agenda. You don't necessarily have to read every line here. I did provide a link, I think, on the next slide, if you'd like to look at it. It was a very full agenda, as you can tell just from these screenshots. It was a very packed agenda. So if you go to the next slide, I can give you an overview that isn't quite so unreadable. So the first day, this started on a Tuesday because it was a holiday on the Monday, Veterans Day. No, anyway, it was a holiday. So we started on a Tuesday. We did, introductions as well as a number of tutorials, and then we started introducing the students to these MEP kits. And really, the MEPs were in pieces, literally in boxes of parts at the beginning of this workshop. So that was the beginning. On Wednesday, the next day, we started the MEP assembly, assembling the mechanical pieces into the Pelican cases that we use to enclose everything. We had a very nice tour of the Haystack facility. And in the evening, to coincide with the center review, we had a networking session. We did some kind of structured networking within the group that was attending the workshop and also with the participants in the center review. So that was a lot of fun. On Thursday, we moved on to some radio propagation lectures delivered by some folks from NTIA, Chris Anderson and Todd Schumann. And we continued with building and testing the MEP hardware and software. And then Friday, we did a field day. So for this field day, we had 3 experiments or kind of tasks, missions, if you like. And we divided the participants into 3 groups and had them rotate through these experiments. So that was a great experience, I think, for everybody involved. It seemed to be a lot of fun, even though not everything went perfectly smoothly. It was fun. And finally, on Saturday, it was the data day. So we brought everyone together to look at the data that was collected from the field day, put together quick presentations on how their field experiments went, and also had an opportunity to collect some feedback from the participants. So let's go to the next slide. I just have some pictures. So we had a bunch of lectures. You see Frank here lecturing and Nick on the other side. Phil Erickson in the bottom left image is our Haystack director, and he was working with the participants for a set of tutorials. The center picture shows the participants inside that big radome you saw in an earlier picture, and the metal structure with red and black webbing above them is the 37-meter telescope. So you can go to the next. So these are photos from our field experiment day. So we had people, outside with big directional antennas. That's the kind of delta-shaped thing that you see Kinsey holding there. And I added some pictures of random RF equipment and power supplies all over the place. They were set up in the hallway next to our coffee station here, as you can see in the bottom left. And
Mary,
we
if
had
we can wrap
improvised.
up to get some questions before I just realized that we have 8 minutes left in the whole session. If you don't
Yeah,
mind wrapping up, thank you.
I've only got one more slide. So we can go to that. So this is some feedback that we received. Folks like the hands-on activities, enjoy being at the observatory, the opportunity to work with their peers in teams, and they really enjoyed the catering, despite one minor mishap. There are some areas to improve. The scheduling was suboptimal for a couple of reasons, and there was interest in more focus on data analysis and software, and the schedule was quite packed. So there's one more thing I want to show. If you could click, yeah. We are working on a software and data workshop tentatively in June. So stay tuned for more details on that. This is intended to support the VLA field experiment that's planned for July. So stay tuned, and that's all I have.
Perfect. Thank you so much, Mary. And I will say from experience in organizing these sort of activities, if the students rated the food positively, that just means, everything, because that's like the number one thing that always gets like, oh, can you give us better food? So, and I think we all enjoyed the food in Haystack. But this is a great activity because it directly connects to the flagship project and the training of students for that. So with that, I want to open the floor for questions and comments on everyone who's in the session. You can either unmute yourself or write in the chat. Comments, questions, we can answer. So Frank has a
question.
Comment. Please.
Yeah, Aylin, are you aware of our upcoming RFI survey and how that can be coordinated with your outreach activities? For example, we will be, as time progresses and we get this technology work completed, visiting a number of SpectrumX institutions and providing hands-on opportunities for students to see the equipment, to even take a drive with us and do spectrum surveys, as well as provide little mini lectures, as would be the interest.
This would be awesome to coordinate. And I know Joel would love to see you here. Yeah, let's talk offline and try to see. I guess the other thing if we can make it to the school, that'd be great, because we're kind of trying to make sure that we have lectures at multiple sites this time as well. So that'll be great.
Yes, please. I will be looking for your emails and somehow coordinating with you on this. So let's definitely make this a valuable activity, not just in collecting photons, but in disseminating information.
Awesome.
Thanks.
Any other? There's some conversation going on in the chat. Students contributing to MEP really helped us find and fix a lot of issues. Frank says, as usual, we learn from the students, so that's a great comment. And then somehow everybody enjoys themselves. Also, I want to say that even though you heard from women, we also are open to working with men. Just as a general comment.
Hey.
You were in you're our, movie star.
There are lots of men that show up to the education and workforce development meeting.
That is
I
true.
feel like that should be
true.
reflected in the minutes.
That is true. I'm at the presentation for the working group today. All right. Any other thoughts or? All right. So please, if you think of anything, reach out to us. Our emails are my last name at ECOSU.edu. We had like a slide that showed our emails. Maybe Anja, if you can pull that up to conclude the meeting. And in any of the efforts, all feedback is welcome. And like I mentioned, our current, immediate stuff that we want to get a lot of things done are the curriculum development and the summer school that's coming up in August. And we're set with our sites. So the registration should be open soon then. All right. Thank you, everyone. And I will hand it off back to Nick. Thank you, Nick.